study. We are about to compare two studies about almost the same activity. We propose our prospective teachers, primary prospective teachers, a task about explaining an arithmetic problem. So our goal was to describe the difficulties there is when trying to explain this property. In one of the studies, we used manipulative material, and in the other, we were supposed to use a little paper and pencil. So this is the property. This is just an example to show that A divided by B divided by C is the same as B divided by B times C. So I mean, divided by 2 is the same as 10 divided by 10 times 2. Yes, we were supposed to include in our activities things like the learning the content, the design of activities by the students, and the construction of the statements. So these were like the missing ingredients we were supposed to use. Our theoretical framework is based on the model called K. Again, this is the MQT domains by the subject matter knowledge and the pedagogical content knowledge. And this is supposed to be like the 6 subdomains that teachers should control in order to be an adequate teacher. In this case, mathematics teacher. We're going to go back to this case in a few minutes. In our particular case, this theoretical framework has 3 parts. First, related to what our work problem is. The second, about the use of manipulative materials and the use of examples. Yeah. Slide was so important that I wanted you to see it clearly. Okay. So, arithmetic properties and word problems. Well, there's a lot of words in the screen, but this is important. We are about to study work in the final years of primary school. These final years, students, primary school students, tend to consider the equal as the means to answer. 5 times 6 is equal to 30. This is the initial knowledge of the sign equal. But at this point, last years of primary school, they have to start understanding the equal sign as a balance between 2 sides of an arithmetic product. Okay? And this is really a problem. It's clear significance of the equal sign. Okay? So one of the options proposed by this in the authors is that maybe working with word problem statements that can be solved in 2 ways could make establishing a relationship between what happens on the left of the sign is the same as what happens on the right of the side of the sign equal. Okay. So word problem is just a contextualized situation where an element is unknown. It's not exactly a problem in the sense that you need a really difficult strategy to solve. Just a contextualized situation to help in our goal of understanding what the arithmetic properties is. Right? So the use of manipulative materials is prepared to establish connections to mathematical ideas, to reverse previous arithmetic misconceptions, but the main important idea here is that there is an internal representation in the students, and there is a manipulative representation with this manipulative material, and the connection of both, the synergy of both representations, fosters a deeper understanding. Okay? So, more than that, from the point of view of the teacher, we use and selection of this manipulative material will depend on the mathematical knowledge of the teacher and on the goals of the teacher who uses this manipulative materials. Sometimes the teachers use manipulative materials to change the pace of the subject, to make it more fun, okay? And sometimes they are like losing the potentiality of these manipulative materials. Okay? So what research says is that a proper selection of material will allow us to make what we wanted to do. Solve the problems in two different ways to justify solutions via the manipulation of these materials. Okay? So everything is getting right together. So what about the use of examples? An example is a particular case, a broader situation, a mathematical object. And this Saslavsky says in this journal, the test must be a didactic intentionality in the choice of the example. So when you are a teacher, you cannot choose randomly the example you give in class. You have to think first, you have to establish an order, from more difficult to the easy ones to the difficult ones, and pay attention to some particular elements. And possible problems is that if you don't care enough about that, you could hide the role of the variables. In this case, maybe those two variables could take the same value. And there are other problems which are not so important. But just summing up this theoretical framework, we had these three big parts: primary school students, to consider assignments and sponsor. The use of examples should follow a didactic intentionality. And when using manipulative materials, we are looking for solving work problems like in two different ways. Okay, and what this synergy said that this will be like the happy end of the history. Okay, but what about our studies? We have developed like two small studies. The first one, and both of them asking for what aspect of this MKT, the are employed when these prospective students are explaining these arithmetic properties. The first study was about using manipulative material. Okay? Both of the goals was the use of manipulative materials and different subdomains that we were interested in. Okay. In the second study, we asked for the same, more or less the same activity, but we were interested in solving on paper. Okay, so more or less two studies, different ways to solve the question. That's what the actual question in study one and study two. We were working with about 30 students, prospective teachers, in their second year of primary education degree. They had no idea. They had no idea about mathematics education or manipulative materials. Okay, they were just at the beginning of the second year, and it was like the starting situation to say, well, you have no idea. You have to learn like a lot about manipulative materials, about the use of examples. Okay, and so, but we identified like 7 different variables. There is a lot of black text in here, but we are going to focus on the red text. Okay, because these 3 variables are the variables that we can analyze in both studies. In the study when we were solving tasks with manipulative materials, and the categories that will be analyzed in the ratings. So the context they were using, the choice of numerical values, and the meaning of intermediate operations. I think there were many others. These letters next to each of the categories correspond to the important events. We are running low of battery. But this is an important slide, so you should read it carefully. Okay. Lots of details there. Okay. Here again. So the importance of the relevance of the activity It's determined by the number of subdomains that it covers and the strength. Okay, there are lots of variables in this specialized content knowledge, which is the mathematics that are adapted to instruction, not mathematics itself, which should be there, but the mathematics adapted to the way you use as a teacher. Okay, in this part, which is the contextualization, it's the knowledge of content and teaching, and the knowledge of content and curriculum. Okay, here again. So, what have we found? Well, there's a column for the written task percentages, there's a column for the video task recorded, manipulative materials, this is the main property, and these three categories, okay, are the way that most of our students choose the numerical values. These three are bad, okay? If you are trying to explain this arithmetic property, and in your examples, always C is equal to 1, your examples are really poor. If you are trying to explain that, and two of the numbers are powers of the smallest, your examples are not that good. If you are trying to explain that, and the quotient is equal to the full number, well, you are not going very well. Okay. So different choices are much better. What happened? In the written task, different choices were like what, 40%, more or less, okay. But in the video recorded task, the big percentages were here. Okay, so the choice of numerical values was much better in the written task. Okay, we have just some examples to illustrate that. Okay, for instance, here this example, two of the numbers were powers of the smallest, 8, 4, 2, or in this case, the quotient was equal to a number. Okay, 2 divided by 3 is equal to 4. Okay. So for choice of numerical values. Okay. This choice of values was better, was more present on the written task. Okay. Another important variable of that is the meaning given to intermediate operations. Okay. Meaning between distribution, if you are dividing, you can distribute 20 apples for 5 persons, 4 apples for each person, okay? Or you can divide 20 divided by 5, considering that you are going to make groups of 5, okay? And see how many groups of 5 you can construct. And so you can distribute, but you can make groups. But at least you have to make some meaning of your division, okay? So most of people, when constructing the video recorded task, show meanings, important meanings, okay? The multiplication is just a repeated addition. And many people doing the written task just made the accountancy or just made some simple drawings, no special meaning other than the formal one. Where we are dividing numbers, even I can paint dots. We are dividing 20 divided by 5, so I paint 20 dots, I paint 5 dots, and as a result, I paint 4 dots, and that's it. Okay, so that was the most common thing in the written task. Well, just as an example, this student was using distribution in both sides of the expression. Okay, different distributions. Okay, in both sides of the expression. This other student was using groups. Okay, so he's trying to divide 8 divided by 2. So he's looking for how many this bar that represents the 8. How many bars of 2 can I put to construct 8? Okay, so meaning it's group. As an exception, this is like the best word we have. Usually in conferences, you present your best words and you hide the bad ones sometimes. Okay, even if this student didn't wrote a word problem, there is nothing more than that. There is no words. But she used, like you see, distribution, grouping, distribution, representing all the different meanings, and even she used slices of pizza because she knew that I was going to present that, or maybe somehow she thought that. Okay, so Here, she was distributing this 16 slices of pizza. There are 8 kids that we can group in pairs. Okay, so 8 kids grouped in pairs. She was forming 4 pairs. Okay, and when she distributes these 16 slices of pizza in these 4 pairs, each pair, sorry, it's in Spanish, each pair is going to eat 4 portions, 4 slices. Okay, so lots of meanings here as an exception. Okay, context. Well, contextualization was present only with manipulative materials. Okay, only this student, the student just so implicitly a context, because the context was there, but it was not properly written. Okay, and, well, the manipulative material promoted more the posing the work product itself. Okay, so just as a matter of conclusion, our 3 variables for the contextualization. Conclusion: merely asking for the verification of a property is not enough to prompt students to create a context. Okay? You have to force them, or maybe be more specific about what we want. The choice of numerical values was richer in the written task. And the meaning of intermediate operation was better, was higher, wider meanings, more meanings, when they were using manipulative materials. Okay? So yes, finally, our conclusion, limited conclusion, because the number of the students, this is just one specific arithmetic property of these things, but the video along with the use of those materials will be combined to promote both different variables. Okay, so as a critical perspective, we are thinking about repeating the same proposal, but asking explicitly a reflection on the 3 important variables that are present on the video task and on the paper and pencil task. And thank you very much for your attention.